So for number 4a, you have a bus just traveling at an initial velocity of 54 kilometers per hour, and its final velocity is 36 kilometers per hour, and it reduced the speed over a distance of 62.5 meters. They want you to find the acceleration. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So the formula is v squared equal to v0 squared 2a delta x. Solving for a, you will get v squared minus v0 squared over 2 delta x. Substituting, you'll get 36 squared minus 54 squared over 2 times 62.5, and you will get minus 12.96 meters per second squared. For part B, they want you to find how long it takes to cover this distance. So you still have the velocity is 54 kilometers per hour. That's the initial velocity, and the final velocity is 36 kilometers per hour. You also have the distance equals 62.5 meters, and they want you to find the time. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So the formula is delta x equals v with v0 over 2 times t. So you will get t equals x into 2 over v with v0, which is 62.5 to 2, 36 plus 54. After solving, you'll get 1.39 seconds. So for part C, they wanted to find how long does it take to come to rest from 54 kilometers per hour. So if the initial velocity is 54 kilometers per hour, the final velocity is 0, and you need to find the time. Still have x equals 62.5 meters. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So the formula is v equals v0 with at. So you have t equals v minus v0 over a. Substituting, you'll get 0 minus 54 over from the previous part. A is minus 12.96, so you'll get 4.17 seconds. For part D, they want you to find the distance that is covered within the 4.17 seconds. So you'll have the initial velocity is 54, the final velocity is 0, and they want you to find the distance it covers. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So the formula is x equals v with v0 over 2 times t. So it's 0 plus 54 over 2 times the time, which is 4.17. The answer will be 112.5 meters. For number 6, you have a car which is initially traveling eastward at A, turns north by traveling in a circular path along ABC. So you have this, here is A, C is over here, and you have a car which turns north by traveling along this path ABC, which is 235 meters, and the car completes the turn in 36 seconds. For part A, they want you to calculate the speed of the car. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So speed is the distance over the time, which is 235 meters over 36 seconds, which is 6.53 meter per second. For number 6 part B, they want you to calculate the magnitude of the acceleration of the car. You already have V from the last question, from the last part is 6.53 meters per second, and you need to calculate R. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So the formula is A equals V squared over R, V being 6.53, and we need to find R. So the length of a quarter of the circumference of a circle is 235. 235 multiplied by 4, that is 940, which is the circumference of the circle. The circumference equals 2 pi r, so that gives you r is 470 over pi. So that's 470 over pi, and the answer will be 0.285 meter per second squared. So for part C and D, they wanted to find the x and the y component when theta is 35 degrees. So for the x component, the acceleration is the acceleration times cosine theta, which is 0.285 multiplied by cosine theta, which is cosine 35, and you'll get 0.233. For the y-axis, it's a sine theta, which is 0.285 into a sine of 35, and you'll get 0.163 meters. So for number 7, part A, you have t equals 0. A grinding wheel has an angular velocity of 24 radians per second. It has constant angular acceleration of 30 radians per second squared until it breaks at t equal to. They want you to find the angular velocity at t equal to. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So the formula is the velocity is the initial velocity times alpha times time. The time is 2. It has a constant acceleration of 30 plus the initial velocity, which is 24. So the angular velocity is 84 radians per second. For number 7 part B, they want the angle that the wheel turned from t equals 0, at which the velocity is 24, to t equals 2, at which the velocity is 84. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So the formula is theta is equal to the angular velocity, the initial angular velocity of 2, all multiplied by time, which is 24 with 84 over 2 times the time, which is 2 seconds, and you'll get 108 radians. So for number 7 part here, they said it turns for 132 radians until it stops at a constant angular acceleration. So it turns for 132 radians more until it stops. And they want you to find the time. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So the formula is theta is equal to the angular velocity with the initial angular velocity over 2 times time. Solving for time, you will get theta into 2 over w with w0, which will be 432 times 2 over 0 plus 84, and you'll get 10.29 seconds. So for number 8, you have a particle moving in a circle of radius 60 centimeters. Started from rest, which initial velocity is 0, with a uniform angular acceleration of 7 radians, 0.7 radians. They want you to calculate its angular velocity at t equals 4. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So the formula is omega equals omega 0 with the acceleration times the time, which is 0 with 0.7 times 4, which is 2.8 radians per second. So for number 8 part B, they want you to calculate the tangential component of the acceleration. The tangential component is the one which is responsible for changing the speed. You have the acceleration, which is 0.7. You have the radius, which is 60 centimeters, which is 0.6 meters. I'm gonna give you a few seconds to answer that question and then I'm gonna come back. So the formula is A tangential is equal to alpha times the radius. Alpha is 0.7, the radius is 0.6, and the tangential component of the acceleration is 0.42 radians per second squared. For number 8 part C, they want you to find the magnitude of the normal component of the acceleration at t equals 4. The normal component of the acceleration is the one which is responsible for changing the direction. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So the formula is A normal is equal to the radius times the angular velocity squared. The radius is 0.6. The angular velocity from part A is 2.8 squared, and you will get 4.704 radians per second squared. So for part D, they want you to find the magnitude of the acceleration at t equals 4. So from part B, you have the tangential component of the acceleration is 0.42, And from part C you have the normal component of the acceleration is 4.704. I'm gonna give you a few seconds to answer the question and then I'm gonna come back. So the formula is A is radical A normal squared with A tangential squared, which is radical 4.704 squared with 0.42 squared, and you'll get 4.72 radians per second squared.